Stokes theorem. What is curl? Curl is defined by, just like the cross product, when we compute the cross product, A cross B, then we usually write E1, A2, B3, minus A3, B2, and so on. Curl is very similar, except that we have operator. So this operator has derivative. So first component is 2, 3 minus 3, 2. Second component is 3, 1 minus 1, 3. Third component is 1, 2 minus 2, 1. We have to remember. Show that X is irrotational. Irrotational means if curl is identical to 0, then we call it is irrotational. IR is opposite. Irrotational, irrational. We make use of identity. Okay, why don't we take this one? Substitute this one. X is, this is x3, x2, x1, x3, x2, x1. Substitute. Okay. However, x, this is 1. Y, x, 0. Z, x, 0. If they are the same, only if these two are the same, we have 1. If they are different, it is 0. So ij, if they are the same, it is 1. They are different, then 0. We find that everything vanishes. 0, 0, 0, 0, 0, 0. So 0. If it is 0, we call this irrotational. Show that the following vector field is rotational. Aha. Curl A is non-zero if it is this. Okay. This is planar radius 2 dimension. We have rho and phi. This direction is E phi, and this direction is E rho, and E phi rotates. This tangent direction of a circle. Okay. We just make use of this. This is A1 and this is A2. We recall this 2, 3, 3, 1. 3, 2, 3, 1, 1, 3. This is wrong. 1, 2, 3, 3, 2. 3, 1, 2. 3, 2, 1. Okay. So what's that? A1, A2, A3 are minus x2, x1, 0. Substitute. This is A3 equals 0, 0, 0. A2, this is x1, x1, x1. And A1 equals minus x2. A1 equals minus x2, minus x2. Okay, derivative. This is 0. 1, 3, different, 0. 2, 3, different, 0. 0, 1, different, 0. 1, 1, same. 2, 2, same. Aha, sum of them is 2 times E3. Curl of a rotating vector, curl of E phi. Curl of E phi will give the normal vector times the 2. This is very important. Stokes' theorem. Stokes' theorem, curve scalar product surface is always expressed in terms of closed path integral of without derivative. Okay, this is a Stokes theorem. Now we'd like to make use of previous result, curve A by making use of Stokes' theorem show that the area of the surface on the xy plane is this. Let's see. Curve A. Curve A was, we just computed curve A is 2e3 when we used this one, e3 axis, and it is a radius, planar radius, and e5 is rotating in such a manner. Curve of this rotating field is 2 times e3. 2 times e3. Okay. This is Stokes. This is without Stokes theorem. Just to use this expression, substitute in here 2 times e3 d sigma. D sigma is this surface vector e3. Okay, so e3 and this e3. This one is a 2 times e3 hat. This one and this one, they are parallel. So this one is nothing but the closed, this surface, this sigma, scalar, area S. Okay, therefore, curve A's surface integral is 2 times area. However, according to Stokes' theorem, curve A's scalar product integral is just a line integral around the closed path. So area is 1/2 integral d sigma dot curve A, right? That this one, according to the Stokes theorem, is A dot dx and closed path. This is a surface, open surface, and this is the closed path C. This is S. This is S, and this is closed path C. Okay. Show that the area S can be expressed in this manner. Let's see. E3 x cross dx. dx is this. If we use Cartesian components, these vectors are constant. So differential is only for the components. If we make use of these components, substitute them in this integral, we have this. Now we remember what was A. A was this. This is typo. We have to delete this D. Okay. Then, because this is a scalar product, 1, 1, and 2, 2. This one multiplied by this 2. So x minus x2 dx1, and here dx2 x1, dx2 s1. And the integral is over a closed path. That means this circle. But let's see. What's that? X cross dx. This is E1 x1 dx2 minus x2 dx1 E2 E3 2 3 1 1 3 3 1 2 2 1. So this we have this one over path the same. They vanish. So why if I take the E3 dot this one, the only contribution is this, and this is identical to this. We make use of this situation. So we have reached the point E3 dot x cross dx 1/2. This is the area of a closed path, enclosed by a closed path. Let's see what it means. A center is inside a path. Closed path is on the xy plane. We have x vector. We have dx vector. Okay, x times the dx cross product. So we can move this one in here. So this is a parallelogram, dx. So x cross dx is represent the area of this parallelogram, and the direction is normal to this plane coming out of the surface. That's the reason why if I multiply E3 hat scalar product with this x cross dx and multiply by 1/2 in that case it becomes this triangle. And if you integrate over the surface, you are adding all of the area of these triangles. What's that? This, if I add all these triangle, infinitesimal triangle, what you have done is to compute the area of this closed path. Okay? So it is a very, very useful formula to compute the arbitrary closed path using this integral.